All right, today we're digging into a paper that, and I'm not exaggerating here, is one of the most important computer science papers of this century. It's called Attention is All You Need, published back in 2017 by a team at Google. And look, it didn't just toss out a new idea, it basically handed us the blueprint for the AI revolution that we are living through right now. So, let's get right into it.
So, to really get why this paper was such a big deal, you have to understand the problem they were trying to solve. You see, before 2017, AI models for language, well, they read kind of like us, but not in a good way. They went one word at a time, in order. But the big question was, what if? What if a computer could just get it? What if it could see the entire sentence all at once and understand how every single word connects to every other word, like instantly? That was the challenge. That was the dream.
For years, the entire field of natural language processing was kind of stuck. They'd hit this massive wall, and that wall was built out of something called sequential processing. This was the age of models like recurrent neural networks, or RNNs for short, and these things had a very, very specific way of doing things, a way that was really holding everything back. Okay, think about it like this. An RNN reads a sentence from left to right, word by word. So by the time it gets to the end of a long sentence, it has to somehow remember what was said at the beginning. And that memory is passed through this long, complicated game of telephone. Now, that makes them slow, sure, but the bigger problem? They get forgetful. It's incredibly hard for them to connect a word way back at the start of a paragraph with a word at the very end. The real goal here was to smash through that one word at a time bottleneck for good.
And the paper itself just lays this out so clearly. You can see it right here. For the old recurrent models, the number of steps it takes, the sequential operations, grows with the length of the sentence. That's what O of N means. It's just a fancy way of saying longer sentence, more work. And that maximum path length means information has a longer, more winding road to travel, making it super easy to get lost. But look at self-attention, the new idea. O of 1. That means the path is constant. It's a direct flight. It doesn't matter if the sentence has 10 words or 1,000. The model can connect any two words in a single computational step. This wasn't just an improvement. It was a total game changer.
So, how on earth did they do it? Well, they didn't just tweak the old models. They didn't just make them a little bit better. No, they took the core ingredient and they threw it out completely. This was the real aha moment, a radical break from everything everyone else was doing. Right at the beginning of the paper, the authors basically just state the facts. They say, look, the dominant models are based on complex recurrent networks. They're acknowledging the status quo, you know? They're setting the stage, painting a picture of how the world of AI worked at that moment. And then, bam. In the very next breath, they drop the bombshell. They say, we propose a new, simple network architecture, the transformer, based solely on attention mechanisms, dispensing with recurrence entirely. I mean, they're not just suggesting a change. They're proposing to completely gut the old way of doing things and replace it with something totally new. That was a huge, bold claim to make. And this right here is the magic ingredient, self-attention. So what is it? It's the mechanism that lets the model look at a whole sentence, and for every single word, it asks, okay, out of all the other words here, which ones are the most important for understanding this word? It's like building a web of connections, a map of meaning, all at once. It's how the model finally gets to see the whole picture. All right, so you've got this incredible new concept, self-attention. That's great, but you need to build a machine that can actually use it. And that machine is the transformer. Its architecture is, honestly, just as brilliant as the idea it's built on. So on a high level, the transformer has two main parts. This encoder-decoder thing was pretty standard back then. First up is the encoder. Its job is to just read the whole input sentence, let's say it's in English, and use that cool self-attention trick to really understand it, to chew on it and digest it. It creates this super rich mathematical summary of what the sentence means. Then it just passes that summary over to the second part, the decoder, which uses that context as a blueprint to write the output sentence, say in German. But that kind of makes you wonder, right? A sentence is complicated. It's got grammar, it's got syntax, it's got subtle meanings. How can just one attention mechanism possibly get all of that nuance? Well, the simple answer is It can't. And this is where another stroke of genius comes into play. The solution is an absolutely brilliant idea called multi-head attention. Why rely on just one pair of eyes when you can have many? The original transformer used 8 heads working in parallel. The best way to think about it is like having a team of expert analysts all reading the same sentence at the exact same time. But each analyst is looking for something different. One head might be your grammar expert. Another is focused only on figuring out what a pronoun like it refers to. A third is tracking who did what to whom. By combining all their different perspectives, the model gets a much, much richer and more layered understanding of the text than any single head could ever get on its own. Okay, a clever design is one thing, but in this world, results are everything. You have to prove it. The authors didn't just say their model was better, they put it to the test. And the results, well, they were absolutely staggering. This number right here, 28.4, this sent a shockwave through the research community. It was the new state-of-the-art score on a really tough English to German translation test. And look, it didn't just sneak past the old record. It blew it out of the water by more than 2 full BLEU points. BLEU is just a way to measure translation quality, and a 2-point jump, that is a massive leap. And get this, it wasn't just beating others' single models. It was outperforming these huge, clunky ensembles of models that had been stitched together. But here's the real kicker. It wasn't just better. It was also way, way more efficient. This chart shows you the training cost, basically how much computer power it takes to get the model working. The previous top models were up here, and the transformer, way down here. It achieved these incredible record-breaking results using a fraction of the computational power. So it's better, it's faster, and it's cheaper to run. That's the holy trinity right there. And the wins just kept stacking up. It didn't stop with German. It set a new record for English to French translation too. It trained in just 3.5 days on 8 GPUs, which back then was an unbelievably short amount of time. And to prove this wasn't just some one-trick pony for translation, the authors threw it at a totally different kind of language problem, something called constituency parsing. And what do you know? It worked great there too, proving the core idea was incredibly versatile. So when a paper like this comes along, it doesn't just set a new high score. It completely changes the game. It sets a brand new direction for the entire field. You could say its publication started as a ripple that has since turned into the massive tidal wave of AI that we are all riding today. And this is maybe the most important thing to understand. The transformer architecture, built on this idea of self-attention, that is the T in GPT. Generative Pre-trained Transformer. It's the literal backbone of BERT, Llama, and pretty much every single large language model making headlines today. So every time you use ChatGPT or any of these other amazing tools, you are, in a very real way, using the direct descendant of the ideas from this one paper from 2017. The paper's title was just perfect. It was a technical term, but it was also this incredibly bold statement. Attention is all you need. And they proved it. They showed that if you throw out the old assumptions and just focus, really pay attention to one powerful new idea, you can unlock a future nobody saw coming. Which really just leaves us with one big question, doesn't it? Now that attention has totally reshaped our world, what should we be paying attention to next?